Hello, everyone. In today's class, we do some data frame Spark experiment using Databricks platform. You might remember that we had some installation of Spark either over your local system manually through AWS EC2 instance, and also, let me just close this, okay. And also through Databricks, and the most comfortable one was Databricks. It's much more easier and there's no issues. And also your next assignment, or previous one actually, which you have 1 week, you need to set up AWS EC2 instance over Amazon website and be able to run Jupyter Notebook. But for today, our experiment is through Databricks platform, which is much convenient and faster. Having said that, please go to your Moodle. And in your Moodle, oh, I think okay. Just a moment, please. So please go to Moodle on week 6, and from class materials, I uploaded some material for today. So download Apple Stock underline CSV, class 1.html, class 1 IP1MB or Jupyter 1, contains null.csv and people.json. So class 1 IP1MB is a Jupyter Notebook. If you haven't installed Jupyter Notebook on your system, you can open class 1.html to copy and paste the codes. Otherwise, you should type the codes that I'm going to work this week. Huh? No, on your local system. You can do it in Jupyter, I mean, in the AWS too. That's totally fine. Just any notebook. But if you have issues in opening a Jupyter notebook, you can open class1.html, and you can let me just open it. So this is class1.html, and as you see, you can see Jupyter notebook codes. So you can copy and paste from this file too. So you don't have to open your Jupyter notebook actually. So I give you a couple of minutes to download those files and open a Jupyter notebook, or again, you don't have to. But for today, class, you cannot run codes over your local system Jupyter notebook because these are PySpark codes. So you have to run it over a Spark cluster. If you want to open it through your Jupyter notebook, in Jupyter Notebook Home, just click on Upload and select the Jupyter notebook from here. Yeah, I think I should rerun my Jupyter notebook because it was deactive. So you can run Jupyter notebook from Anaconda or directly in your Windows tab. You can just type Jupyter and open it. So in the Jupyter Notebook Home, click on Upload. Select the notebook. Then click on Upload and open your notebook. If you see, it doesn't look great in Jupyter Notebook because I exported from Databricks. So there is some limitations, but still you can copy and paste the code into your Databricks instance, and it's much more convenient. Also, for accessing to Databricks, I already gave you the link in the previous PowerPoint. So you can click on community.cloud.databricks.com/login. And in the login page, enter your username and password and sign. So I give you like a couple of minutes to do all of them. So download the CSV files, JSON files, and Jupyter Notebook files. Also log into your Databricks account.
Professor?
Yes?
Should we put the JSON file into the Jupyter Notebook?
No. Just download all of them. So
Yeah, I put those CVS and IPass onto the Jupyter Notebooks.
So you don't have to.
Oh, okay. Thank you.
Okay, so now we want to work with Databricks. So in order to able to work with the Spark, you should first activate your cluster or instance. Databricks is very convenient. You don't have to do that, but a standard way is first run your cluster. So for running a cluster, go to data on the left side of Databricks. You see the data icon. Oh, sorry. Click on cluster. As you see, I already terminated 2 previous clusters. But again, after you work with the today's assignments or jobs, come here, select your cluster, and just terminate them. It's a good practice. I don't think they charge you in the Databricks, but definitely they charge you over Amazon. So it's a good practice to terminate your cluster after using. So on clusters, click on the create a cluster, put the arbitrary name. Let's say class. Be sure that Spark 3 is chosen. And just create cluster. After you create cluster, it might take a few minutes to run it. Okay, until it's getting loaded, Databricks lets you even to upload your files, but it's on the standard way. So on data, click on data, and then click to add data. And drag and drop your files. For example, drag and drop everything except for your Jupyter Notebook. So for example, JSON, just drop it here. Look at here. When I drag and drop it here, it's my file address /file store /tables /file name. You can drag and drop CSV files too. Again, file store tables contains null.csv, and also the last. if you see here, we have these are the file locations that we work with them later. Again, go to cluster, and for me, my cluster is still loading, but the standard way was just waiting for it to get completely loaded. But for saving time, I first load the files, then wait for cluster to be fully loaded. No, just click on add data and drag and drop your files. What I'm doing now. So after drag and drop your files, you don't have to do anything. It's automatically do the rest for you. So it's one of the reasons I'm saying database is much more convenience. It takes care of so many things that otherwise you should take care of. As you see next to my class, the icon is green. I wait 1 or 2 minutes more for all of you to get your cluster running. So the state is running now. After you finish the today work, come here in the cluster sections and click on termination. Okay, now we have our data is loaded. Also, our cluster is running. Now we can run some Spark codes through the Databricks notebook. So on the left side, click on the first icon. For you guys, create a new notebook. Put any name. Let's say some practice, whatever arbitrary names. Be sure the default language is Python and just click create. So step by step, just copy and paste the codes from the notebook. Ctrl+C, Ctrl+V. And just shift enter to be able to run the code. I already run all of the code, so I have on my system. By the way, PySpark is built over a Spark SQL. What does it mean? There is so many common commands, and also you can use SQL commands within PySpark, which brings you extra ability. Also, you can leverage your SQL knowledge in the PySpark, and which gives you a lot of flexibility. So from PySpark SQL, I import a Spark session. Then I make a app, which here doesn't help because the code runs too fast. You don't have to even look at the app. But it's a good practice to do that when we work with the large data. You can see what is going on. So we create a Spark session, and on top of such session, we make an app with get or create method. You might remember we had OS package in Python. Like here, you can find the current working directory. So I import OS and print os.getCwd. So with this command, I can understand what is my current working directory. As you see, the current working directory is Databricks/driver, but my files were uploaded in another folder. So when you drag and drop, it shows the folder which is different from working directory. So first we need to import people.json. And when we drag and drop, we already saw the address. So if you didn't change anything, your address should be same as me. So as you see here, from Spark read.json, this is a function over a Spark session that we just created. So we are reading people.json and assign it to a variable with the name of that. Again, you don't have to type with me. I already gave you a notebook. You can copy and paste here, but you cannot run on your local Jupyter notebook because that's for a PySpark running over clusters. Okay. So as you see now, we created a Spark. We run a Spark jobs and we created this that Spark object. Similar to Python with the show method, you can see what is inside your data frame. So as you see data.show, and I have two columns of age and name, which is there's a null in the age column. Now I can look at the structure of my data frame with print schema. With print schema, it's just showing me the data has two columns of age and name. Age has a type of line. You look at the parentheses, it's just saying nullable equal true. It just means it's let to have null values or NAs. Name is a string. Similar to Python, with dot columns, I can see a list of my column, which is age and name. With describe, again, you can see the type of your data, and we can show it as a data frame. So over data.describe, I'm calling a method of show, so I can see it as a data frame. As you see, for age, mean, max, standard deviation. For name, I have count. I don't have mean, standard deviation, and we have mean and max, but it's basically just alphabetical order, so doesn't make sense that much here. So as you see, I had a JSON file, and PySpark guessed the type of the columns. So I can define and let PySpark knows what kind of data I'm entering. So I could define them manually without relying on PySpark, but I need to import some functions to create a structure for importing my data. It's the reason from PySpark SQL types, I'm importing a struct field, a string type, integer type, struct type. With the struct field function, I define my type of field. I'm just saying age has type of integer, and true means it could take empty or null cells. I'm with this again with the struct field, I'm creating a field with the name that is integer and could have null values. I need to create that structure as a schema. So with this struct type, I'm creating a schema. Now I have a schema or structure that I can use it for entering my data. Look at next block. I'm calling a Spark read.json file address. I'm just saying this time, I'm saying don't guess by yourself. Use my structure or a schema for entering the data. So as you see now, it's reading the JSON with the structure that I defined. Now, when I print the schema, look at here, age is integer, it's not long anymore. Let me go back. Previously, it was a long variable, long integer variable, which is automatically created or defined by PySpark. Here, I manually said it should be an integer. Any questions so far? Let me see your friend. Last class you didn't post over grouping to get a bonus. It was some Mac issues that you resolved. It didn't? Okay. Okay. Very interesting. So your friends trying to run these codes over AWS, hopefully they can, but for avoiding issues, I try to do it over Databricks because I could pretty sure that could all of you could run the codes. So now I imported the data. I can use either SQL commands or Python commands because PySpark is built over SQL. Look at here with df.show, I can show my data frame. With df bracket column name, I can use it for calculations. So you don't see what is inside that column, but you can use it later. And when I go to the type is as column. With select method, I can take it as a data frame, not a column type. So without select is just a column type, but with select, you can take a column as a data frame. So since with the select, you took it as a data frame, you can run show method on top of that data frame and see the column as data frame. Again, similarly, you could call head function. I'm just playing with some Python code. So df.select you can define a list of columns, and with dot show, you can show the values. So we have a with column function. With column function, you can create a new column. Oh, sorry, with column method. So df.with column parentheses h2. So I'm just saying that I'm creating column of h2, comma, and after comma is the value that I'm going to assign to the new column. So the value would be df bracket h times 2. And I'm assigning it to a new column with the name of h2. And with show method, you can see that. So age, name, h2. So as you see here, on top of multiplication, you can do a square root or other function and just simply creating a new column. So the only point that you should take in account that you should use with column method. So we have method of with column rename. df.with column rename. You can rename your column. So my column was age. I want to rename it as age1. With dot show method, I can show a data frame. So as you see, the results is age1 instead of age and column of name. So I wait a little bit, give you a couple of minutes to play with the code so far. And also, if you have some questions, you can ask from me. Even people over Zoom, you can either text me or use your microphone to ask questions. So again, Python gives you the capability of working with the SQL commands. You can, one of the more convenient way of working with SQL in PySpark environment, just making a temporary SQL view, which I'm doing here with create or replace temp view, calling this method over data frame that I imported, and save it as guys. So guys is an arbitrary name here, is a SQL temporary view that I mask it over my data. Now I can run SQL commands much more easier over that SQL temporary view. For example, here, look at this. With the spark.sql, I can access to the SQL command. So look at the command within the parentheses, Spark SQL parentheses, select star means everything from guys. It is very simple and obvious SQL commands that probably is the first command that you learn in SQL. With dot show, I can show the result of my query. So similar to the previous one. So again, it gives you ability of working for both SQL and Python codes within the Spark environment. Let's do another one. So this time, I'm with the Spark.SQL, I access to the SQL command. This is again another simple SQL command. I'm saying that select everything from guys where age column is more than 25. So, and is 30, so it's the only one that would be selected here. So let's import the next data frame, which is stock values of Apple in, I think, 2010 and after that. So as you see, I'm calling read.csv method on top of a Spark session that I created. First, I put the address over my Databricks platform. Then I'm saying that guess the schema by yourself by looking at the data, guess the schema or structure. For example, again, it just means which columns are string, which columns are numeric. And I can either define by myself or let Python to do by itself. And with header equal true, I'm just saying the first row is header, it's not that. I'm importing the data as a CSV and assigning it to a stock. And now I can print a schema. It seems, to me, it seems to be a right schema. So date is a string, open, high, low, close, volume, all of them are numerical values, and also adjusted close price is also a double, which is a numerical value. What happens? Again, with the show method, I can see a snapshot of my data. So here we skim through some Python and SQL commands over a data frame. It's not limited to this. There are much more commands, but these are very essential. It's most likely you need it in your project. But for your specific need, you can Google and find some other Python commands, PySpark commands, or like SQL commands that you need. I don't evaluate you for your SQL knowledge, but you can easily leverage your knowledge here and brings you a lot of flexibility. Look at here, a stock filter, and I'm just saying over the column of open price, give me all of the prices that are more than 300 and show it to me as a data frame. With select method, you can just show the columns that are more interested to you, not all of them. So for in the previous one, I'm showing stock data frame, limited or filtered it to the open prices more than 300, and just selecting open and high price values, and show it the values here. So a couple of your friends are trying hard to run it over AWS. If they cannot, give them really good bonus because it's a difficult task. But we'll do it later, no worries.
We have already done in database.
Could you bring it?
Yeah, already done in database and trying to do it.
Could you be able to run it in AWS?
No, I'm
Okay. No worries. I mean, if you can teach your friends sooner than me, I give you a good bonus. You can make it. You too can make a YouTube video and just upload it, group me. I give you a really good bonus. But I teach them in like 1 or 2 weeks. Okay. So select open high, I think. Okay, so these are like filter or select. They are more look like SQL type of commands. If you want to do Python-like, look at here. Instead of saying select, or filtering, I mean, look at this filter and this filter. I'm just saying the column of open from stock. This one is more look like SQL commands than this one. The second one is more look like a Python command, because I'm just saying a stock with the stock data frame column of open. Again, just show you how it's flexible to just jump back and forth, and the results are exactly the same. Any questions so far from even people over Zoom? Okay, there is one question. Okay, one of your friends asked about how should we, okay, it's your assignment actually. Just Google it, it's very easy, and you should do it by yourself. It's very straightforward. I mean, it takes like, yeah. So for applying as a student, I mean, I think you should apply, I mean, you should use your university email. So you are a graduate student. Some of your learning comes from you. If you go to PhD, almost all of your learning comes from you. So in more graduate level classes, people just guide you, give you general guide, and you should learn everything by yourself. As a master, some of your learning comes from me, and some of them again by your practice. So we can consider some conditions when we call observations from the columns. For example, we can use this symbol for and, this symbol for or condition, and this one for not condition. Look at here, I'm filtering stock price, so open stock price of more than 200 and less than 300. So everything between 200 and 300. I put the or condition. Also, I'm interested to stock price more than 400. I limit my report to open and high columns and show the results. This is a snapshot. So every value that you see here should be, I mean, when you do the actual calculations, should be between 200 and 300 or more than 400, because we also have the or command here. Look at not command. I'm just saying that filter my observation to the open prices are more than 200, but there's a not here, and not more than 250. What does it mean? All of my observation from open price should be between 200 and 250, because I'm not interested to anything more than 250 with this not condition here. Or equality, I can say, show me any open price, any observations that their open price is equal to 11.75. With show method, I can just print my observation, but for doing calculation over my observation, I'm calling collect method. As you see, when I call my, I do this operation and assign it to my result. When I want type my result and run this block, I just see this outcome. It's not printing, just showing me a general idea about the object that I have. See, with dot collect method, I can do calculation over my result. For example, I'm just saying that as a list, show me the first element with the indication of 0, and show me as a dictionary. As you see, the column are the dictionary keys, and in front of them, you can find the associated value. Here, showing it as dic. And again, I limit my dictionary to the key of volume. In front of volume here, I have 119, 282, 800. And this is the exact value that you see here. So I give you 1 or 2 minutes to play with the code so far. And if you have questions, you can ask me. Okay, one of your friends' question. I want to buy lessons on DataCamp to review the codes. Which lesson should I buy? I already bought NumPy and Pandas. Okay, let me look at the DataCamp and I respond to your question later. One of your friends wants to review Python codes. I already gave you some PowerPoints. But just email me later or put on, ask your question or group me so I won't forget your questions. And I give you some instruction how to get to DataCamp codes and review the Python codes that you need. Okay. Okay. By the way, you can call me Hamid. You don't have to call me Professor. I know it's very nice of you, but you don't have to. So one of the things that you need to take into account how to deal with the null variables. It's either in independent variables or dependent variables. When you have empty or NAs in independent variables, you can either impute or drop the observations. If your columns are too much empty, let's say 90% of a column is empty, dropping makes sense. But let's say 70 or 60% are empty, is a good idea to impute your observations. Because if you just drop columns, in many cases, people will criticize you if you are biased on certain variables or you don't consider some variables. On top of that, also you can drop some observations, but we usually try not to drop observation unless the values doesn't make sense at all or too many empties. But you might remember we had an example in the previous class, or previous course, should I say, that Apple created an algorithm to grant credit cards or credit scores to people. And they are very bad for females. One reason could be, I don't say it's the reason, I just say potential reason. They didn't have enough observation for the females. Maybe they dropped some observations or any other issues. Potentially, if you drop so many observations for females, your model doesn't train very well for female observations. So I don't, but you know, algorithms are not sexist, but they may act as in a sexism way. So look at this example. By the way, just a question, people over Zoom also can answer. So if we have empty cells or NAs or null values in the dependent variable, Should we impute or shouldn't we? What? You shouldn't? No, dependent variable you never impute. You just drop the observation. Independent variables you can, but dependent. Yeah, whenever you have dependent variable, don't impute. The only time that we definitely should drop observations for dependent variable. So let's look at this example.
One of Apple's co-founders is accusing the company's new digital credit card of gender discrimination. Apple introduced the card in August, partnering with Goldman Sachs as the issuing bank. Applicants go through a credit approval process. Last week, one tech entrepreneur said the algorithms being used are sexist.
Apple co-founder Steve Wozniak tweeted that he got 10 times the credit limit his wife received, even though they have no separate accounts or separate assets. Apple deferred to Goldman Sachs, which tells CBS News, quote, "Our credit decisions are based on a customer's credit worthiness and not on factors like gender, race, age, sexual orientation, or any other basis prohibited by law." CBS News contributor and Wired's editor-in-chief, Nick Thompson, is here. Nick, good morning.
Good morning.
So cast your mind back to the old days. You apply for a credit card and somebody sits behind a desk and looks over your application. Now a computer's doing it.
Sure.
Is this computer system at Apple flawed?
It could be flawed. It could be biased. One of the big problems of our time right now is that biases are very hard to pick out because they're built into really complex algorithmic systems. In this particular case, though, there is another explanation, right? Steve Wozniak is one of the founders of Apple.
Yes.
He makes a lot of money.
Company. Yeah. Yes.
And so if you make a ton of money and your wife doesn't, and you apply for separate cards, you might get different credit limits because your credit limit is based on your credit score.
Yeah, but he was saying they weren't segregated. They're
Apple cards, you apply for different accounts. Okay. So he's applying for a different account. There is an easy explanation. That doesn't mean the system isn't biased. It doesn't mean it isn't rigged against women. It's just the data we have right now is not the most compelling example.
Can you make algorithms more transparent? Is that possible?
It is very, very hard because part of the nature of artificial intelligence is that the computer is making decisions that the human doesn't make.
Yeah.
So for a lot of AI algorithms, you just say, optimize for X, optimize for Y. So for example, in credit approvals, you might say, look at all the data and optimize for a system that minimizes defaults. And then you don't know what goes into that.
You're saying some of these companies don't even know how their own algorithms work.
They know what the algorithms are trying to do. They don't know exactly how the algorithm is getting there.
Yeah.
So you can try to audit it. You can try to break it apart. You can look at different factors, take different inputs. But it is a complicated process. It is one of the most interesting questions of our time.
Really?
How do we get justice in a system where we don't know how the algorithms are working?
Go ahead.
Well, you could argue for an algorithm because it's not that old white bank manager making his decision, one guy behind a counter. It's now a machine, and that doesn't have the biases we do. But if the biases are built in because a programmer put them there, like you're stuck.
Or the data put them there. But one of the reasons why when this story broke, I was a little skeptical is that probably the system is set up to do what I said before, right? To minimize defaults. And a system that's set up to minimize defaults is not going to give all men 20 times the credit limit of all women. Perhaps it will have a tiny difference based on historical data. I would expect maybe it would be beneficial for women who are maybe more responsible with their credit. So this story sounds like it probably, the outcome we're seeing is probably connected to the very high income of the tech founders tweeting about it.
So doesn't it seem like there's a bigger problem here than what it appears to be?
I think this story is probably not the best example of a huge issue.
All right. Nick Thompson, thank you very much.
So as you see, the guy was talking about also importance of the data. So in your final project, taking account take your data seriously, look at your observations. You might sometimes do imputations. Also, whenever you drop a column, should make sense. You shouldn't drop columns if you see or too many observations. But let's do some NA commands with this sample data frame. For example, with NA.drop, you can drop all the observations that have NA. but also you can limit it. So you can say if at least 2 of them are NAs, drop it. So with thresh equal 2, I'm just saying that only drop the rows that at least 2 of the observations are null. As you see, employee 2 has 2 null, so it's the only observation that is dropped here. Or I can say if all of the observations are null, drop it. So since even for employee 2 we still have ID, it has not dropped. So you can also limit your drop to the certain columns. For example, here I'm saying that you drop, but just consider sales. So if there is any NA on sales or null values on the sales, drop that observation. So for employee 3 and 4, we have their sales value, so it keeps. But for other employees, 1 and 2, we don't have any sale value, so they are dropped. Here we are printing a schema. As you see, ID is a string, name string, and sales double. With this, you can also make your schema, and you don't have to limit yourself here. Also, look at here. I'm now imputing. I'm saying that with any .fill method, I can impute. I just say impute with the string of a character. Look at here. The name is the null values in the name column imputed with a char, but in the sale there's a still null. Spark is kind of genius because it looked at the imputation value is a string, and look at here. Look at the schema. The ID and name has a string type, so it just imputed for the columns that their type are a string. So it's the reason sales is a double, is a numerical value, so it has not been imputed. Look at this time, I'm on top of NA fill method, which is for imputation. I'm calling another method, same method with another value of 0. So this time it does imputation of string column with a char, and also 0 is a numerical value, sales is a numerical column, so the imputation over sales is 0. Same as before, you can limit your imputation on certain columns. For example, again, here with na.fill, I'm imputing a name, a string, and it doesn't search for all the string column. I just limit to the name column, and you see the imputation. These are simple imputations. Sometimes you want to do some more complex imputation, like finding the mean or median for numerical column, or mode. Or mode means most frequent observation for the categorical or string columns. So we need to import. Here I'm using mean for imputation. I'm importing from PySpark SQL function. And look at here, I'm saying that over data null data frame, and calculate mean of sales column. Also, don't print, just collect. With method of .collect, you can keep the value. So imp imp underline mean is an object with the value of 400.5. Now I do imputation. I want to do na.fill for imputation. I'm doing imp underline mean 0, 0. It brings you the exact value, not whole of the list. And I'm just saying impute over sales column, which is the numerical one. And with .show, I can print the whole of data frame. As you see here, now the sale column imputed with the mean value of 400.5. Again, these are very basic or easy column. You can, for your project, probably you do imputation for several columns. So any questions so far? Oh, there's a question over. So today class is we are doing Databricks notebooks, because your friends also working on understanding how to run Jupyter Notebook over AWS. Please keep your question for now, and later that we start, we do some experiment over AWS, I get to your question. So don't forget your question, but for now, our focus on Databricks, and we get distracted if I go to AWS questions. By the way, let me show you an email. There is a midterm survey. Please, if you haven't received it, I'm going to forward this link. Please answer to the question. I look at your answers and get some feedbacks about your ideas about the class. So hopefully we can do some improvement for the remaining of the semester. Okay, let's go back to the event stock price data frame. With select method, I can show you the columns that I'm interested in, not all of it. Now I want to do some data date transformation. Like for example, what are the month, year, and date, I mean hour of my date column. So as you see, for example, the first values are the year, second month, the third is day. So I need to import some date functions from PySpark SQL.functions. I imported day of month, hour, day of year, month, year, week of year, format underline number, date underline format. For example, with day of month, I can just show which day of the month I have. Like, look at the first one. Day is the 4th, second of 5th, 6th. When I run day of month function here, I can see just the day value. Similarly, I can find the month value of the column, like all of the January except for, I think, the last. Yeah, this one should be February here. Also, with column, you can create a new column. As you see, over a stock data frame, I'm creating a new column with the with column method. I'm creating a year column, and the value is by running year function over date column of a stock data frame. This is my last column here. So let's have a question. What is the annual close price? So one way is just after creating a year column, I do the mean, but as you see, it just gives you the mean of, oh, sorry. For making the annual close price, I can group by them by year and then calculate the means. So group by again is a SQL command. Look at here, with first row, I'm creating a year column here or here. Then I'm just saying that group by year. Here you just see 2010, but I think it's from 2010 to 16. With mean function that I imported, I can find the mean of each year that I grouped together, and you see here. There is some issues. First of all, maybe I don't need all of them. I just want close price. Also, the names is sloppy. Maybe I just want to have year column and annual close price. You can. There's several ways of it. Here I just do one way of dealing with that. Maybe first you calculate the average, then limit your columns to just 2 columns, or even from early, you can just focus on 2 columns. Like here, if my data set is too big, I don't want to do mean calculation on all of the columns. I just want to select first 2 columns, then group by year, and then calculate the mean. So when your data set is too huge, it's much faster to just focus on the data that you need. Again, the name doesn't look good. Maybe you can just change the name later. Here is another approach. So here I'm just selecting the year column and average close column. So these are grouped by year, and also I'm taking the mean or average of each year. With column rename method, you can rename it because average parenthetic close maybe doesn't look great. So with column rename, I'm just saying that from this table, take this column name and change it to average annual close price. And this is the result. So maybe we can do some modification. Again, these are some sample modifications. You can, based on your project or your goal, you might need to Google and find new comments. Definitely, we don't have time to cover all the modification that we can make on a data frame, but these are some just good examples. For example, I want to round it up to 2 digits with format underline number. I'm just saying that take this column and round it with 2 digits. As you see here, now I have just these 2 columns, and the column is rounded with 2 digits. Again, name doesn't look great. One way with the column renamed, we can change the name of this column. Another approach, even from early beginning, we take it with the alias name. Look at here, I'm just saying that select a year and also round average annual close price with 2 digits, but don't take it with the default name, with the alias name of average annual close price. So the previous name would be in the better format. Alias, it just means, it's similar to my email address. You have noticed that I have 2 email addresses. One of them is hahadi.dolasar@clarku.edu. It's much more longer and not convenient. I have an alias email of hamid@clarku.edu. So 2 different names, but same values. So if you email me to any of them, I get your email address. So same here. Instead of this very long name, we take it with a more convenient name of average annual close price as the alias, and assign it to the column value that we rounded up with 2 digits. Okay, so alias, if I don't take, okay, look at the previous block. I'm taking the year column, and also I'm saying take this column, average annual close price, with format underline number, you round it up to 2 digits. But when you print the results, a snapshot of results, look at the name, format underline name, average annual close. So instead of taking this name, which doesn't look good, I'm taking it with the alias name. So I'm calling alias method and saying that this is the alias name that you should consider with that column, for that column. Yeah, just name change. Again, it's not the only way. With column rename, you can rename the, I mean, these are just, and these are, I mean, with column rename, you can do exactly similar thing. So again, these are some modifications based on your project. Maybe you impute with mode or median or those kind of things. You just need to Google and find the equivalent function and use it for here. Next class, we also cover some more data frame operations, and then from next week, hopefully we start machine learning applications over PySpark. And when we started, again, I go back to the Hadoop core because a little of it is remained. It's not very important, but I wanted you guys to first start PySpark because you get some idea about your project. Also, hopefully, which I'm confident that we have time to run some experiment over AWS, because I assume if you get a job in somewhere, right now it's a very common tool that, especially I think in startup companies like to work with AWS a lot. So any questions for today? Okay. Please run some experiment, no worries, Databricks doesn't break. After you finish your work, come here over the cluster that is active and select this icon, which you terminate your cluster. Is that very necessary here? Yeah. Databricks has this capability to close it, but Amazon AWS doesn't do that. I'm not sure why. So, yeah. So, okay. That's for today, and thank you very much. Have a great rest of the day. Yeah, you have a question. What's your question?
Yes, just about assignment.
Okay, what's your question?
I told you in a group meeting. I did some research how to apply student credit, and I found that I have to register AWS Educate in order to get a student credit. And when I already registered to AWS Educate, I did not get a student credit. I contacted AWS team, and they said that they no longer provide us a student credit anymore since the end of last year.
Oh, they stopped doing that?
Yes, I show you an email in GroupMe.
That's fine. I mean, as long as you apply, that's fine. Just show me the email that you applied, and that's totally okay.
Okay, thank you.
Thank you very much for letting me know.
Yes.
So yes, up to last year that I taught this course, they used to grant. Maybe they stopped doing this year. So, I mean, these are their own company, and they have their own Hadoop flavor, and it's what happens. But if you also can run a sample cluster over your own local computer, so you don't see such a frequent change. Even I said I wanted to teach you Cloudera, but Cloudera is another flavor of Hadoop, which you make a virtual Hadoop environment on your system, but suddenly they stop providing it. So it's the reason I changed to Horton Sandbox. So these are their own company, and they probably make changes. But thank you. As long as you apply, you get your assignment.
Okay, thank you.
Thanks. Bye. Any other questions? No? Okay, cool. And have a great rest of the day.